Have you ever wondered why the area of a circle is pi times r squared? Let's not just accept it. Let's prove it. A circle of radius r sits on a coordinate grid. A line from the center to the edge traces out the radius r. The angle it makes with the horizontal is called theta. The tip of that line has coordinates x and y, and the circle itself is described by the equation x squared plus y squared equals r squared. To find the area, we begin by stacking thin vertical rectangles under the curve in the first quadrant. Each rectangle has a width of dx and a height equal to the y value on the circle, which is the square root of r squared minus x squared. Watch as we keep adding more and more rectangles, thinner, more precise. They fill the quarter circle perfectly. Since all four quadrants are identical, the full area is exactly 4 times this quarter circle region. That means a equals 4 times the integral from 0 to r of the square root of r squared minus x squared dx. The square root makes this tricky, so we'll use a clever trigonometric substitution. We let x equal r sine theta. Then dx becomes r cosine theta d theta. When x equals 0, theta is 0. And when x equals r, theta is pi over 2. Substituting into the square root, we get the square root of r squared minus r squared sine squared theta, which factors out to the square root of r squared times the quantity 1 minus sine squared theta. Now, recall the Pythagorean identity. 1 minus sine squared theta equals cosine squared theta. So the square root collapses cleanly to r cosine theta. The integral now becomes 4 times the integral from 0 to pi over 2 of r cosine theta times r cosine theta d theta, which is 4r squared times the integral of cosine squared theta d theta. To handle cosine squared, we apply the half angle identity. Cosine squared theta equals 1 plus cosine of 2 theta all divided by 2. Substituting that in, the integral becomes 4r squared times the integral from 0 to pi over 2 of the quantity 1 plus cosine 2 theta over 2 d theta, which simplifies to 2r squared times the integral of 1 plus cosine of 2 theta. Integrating term by term gives 2r squared times the bracket theta plus sine 2 theta over 2 evaluated from 0 to pi over 2. Plugging in the upper limit, sine of pi vanishes to 0. Plugging in the lower limit, everything is 0. We are left with 2r squared times pi over 2, and that equals pi r squared.